do we know what a sphere is? Yeah, let's find out what a sphere is. And let me start with this fellow. And his name is Euclid. We always go to Euclid. Why? Because he was the guy who formalized all this stuff. He was a Greek guy, a Greek citizen. He lived really in Alexandria, Egypt. That's where he did his work. But he did go to Aristotle's school, okay, in Athens, the Lyceum, and again in Athens, and that's where he got his education. Then he went to Alexandria, and he wrote this book, kind of condensed all the knowledge of the Greeks regarding geometry in those days. And he came up with these definitions, which again, they're not really his, because you'll see that in Aristotle's book on physics, he has that same exact definition, that which has no part for the point. You'll see it if you look up, I think it's chapter 6 of physics, and you'll find that same definition. Okay, I don't remember the chapter now, but I can look it up. Anyways, that which has no part was around. That was a notion that the Greeks had, meaning it has no dimensions, it has no size, no volume, no anything. That's what a point is. That's how they defined it. And what is a line? Well, a line is breadthless length. And again, what is it? What is a line made of? Made of points. What were the points? Zero dimensional, nothing there, no dimension, no size, no anything. And so a straight line, the fourth definition there, is a line which lies evenly with the points on itself. A line is made of points. It's regarded to be one-dimensional today. He defined it as a bunch of points, which again, he was referring to locations. So a line is a bunch of locations, meaning an itinerary, and there you have what a point is and what a line is. Nothing. There's no such thing as a point or no such thing as a line as a geometric figure. There is no figure called line. There is no figure called point, because point is location and line is itinerary, motion. That's what it is. Okay, that's how it's defined, and that's how it's used. Geometers, physicists, mathematical physicists, they have no use for objects. And that's why the word object has never been defined. You won't find a single textbook of physics on planet Earth in any country that begins with the definitions of what an object is. Okay? Why? Because they never use objects. And you would think that if you can't do physics without objects, meaning you cannot explain a mechanism without an object, then the first word you need to define is the word object, because the first principle of physics is that you can't do physics without an object. Just that simple. Okay, so where do we go from here? Well, here we have the line of mathematical physics today, and it's an itinerary. It's a bunch of locations. They depict them with little points, little dots, but each one of those dots has 2 dimensions, because you can see it. There is no object that is 1-dimensional or 0-dimensional, let alone 4-dimensional. So, they have to put a dot in there to put something physical so that you can relate to it. Because what are they going to put? The word location in there? Are they going to put the word motion or displacement or itinerary? What are they going to put in there? So that's what it is. That's what the line of so-called geometry is today. It's not a geometric figure. It's just an itinerary. Okay, and why is that important? Well, because here you have Euclid's circle, which he defined in the same way, essentially. Okay. And he says in first three definitions involving the circle. So definition 15, a circle is a plane figure. No, it ain't. Not to this day, it ain't a figure. Okay, but contained by one line. Remember what it was? A line, a bunch of points, a bunch of locations. That all the straight lines falling upon it from one point among those lines within the figure equal one another. In other words, the center point. Okay, so there you have it. That's Euclid's notion of a circle. It's just a bunch of rays going from the center to a point that makes up the line, the curved line that encapsulates what is known as a circle. Okay, and no, in fact, the geometers today, the mathematical physicists, they will clarify that the inside of the circumference, what's inside of it, is not part of the circle. They say that it's the circumference which is the circle, and if you include the center part, it's called a disk. So what is the word circle for then? If all we have is circumference and disk. And then definition 16, and the point is called the center of the circle. There you see it, okay? And definition 17, a diameter of the circle is any straight line drawn through the center and terminated in both directions by the circumference of the circle. And such a straight line also bisects the circle. Okay, and you say, Bill, why do we need to know all this? I thought we were going to talk about spheres. Well, please have a little patience. I'll get there, okay? Give me a chance here. So what is a circle according to mathematical physics today? I mean, is it any different than this? It's slightly different, okay? It's the same thing, but it doesn't include all these rays, okay? And here it is. This is what it is. Okay, it looks like this. Similar, but without the rays from the center. The circle today is just an itinerary, an orbit. That's what it is. It's an orbit. And you see two definitions there, both of them pulled out of the Wikipedia. All points in a plane that are at a given distance from a given point, the center. And what's the other notion? The curve traced out by a point, meaning a location, right? That moves in a plane so that its distance from a given point is constant. In other words, it's the orbit of a location. That's what a circle is. And if it doesn't include the center, well, I don't know how it can be called a plane. All we have is really a little line, which is really not a line. It's just an itinerary. It's an orbit around the center. And that's what they call the circle. That's not a plane. Not a plane at all. And certainly not a figure. Okay? Because an itinerary is not a figure. And again, you say, Bill, why do we need to know all this to know what a sphere is? Well, here it goes. Okay. From there, we move on to the semicircle. Okay. We need to know all these notions to know what a sphere is. Okay. That's why I'm putting all this up here. Okay. Here's the semicircle. Okay. According to Euclid. Okay. What is it? A semicircle is the figure. Yes, figure. Okay. Contained by the diameter and the circumference cut off by it. And the center of the semicircle is the same as that of the circle. So that's a semicircle. It's half of Euclid's circle, which includes all these rays, okay? And again, all these rays, they do not make a plane. A plane is a continuous surface. This guy is saying, no, it's a bunch of rays, a bunch of arrows, lines, whatever, and each line is an individual unit, and between any two lines, there are gazillions of lines. Okay, because they're not talking about lines, because they're talking about itineraries, and itineraries are made of locations, and between any two locations, you can fit gazillions of locations, because it's a concept. It's not a physical object. Okay, you can't just be making the point smaller and smaller and smaller. That's not what it is. Okay, what we're talking about is locations. That's why they say that between any 2 points, you can fit gazillions of points, because they're not talking about physical objects. Physical objects, you cannot fit gazillions of points between 2 points, because you just got to find out what the size of the point is, and there is only a given distance between any 2 points. You can fit only so many points in between. But when you turn the point into locations, well, you can fit as many locations as you want. And time also, you can fit as many seconds as you want between there, or gazillions of a second in between there. Okay, and what is a semicircle according to the the illustrious mathematical physics of today? Well, here it is. If I can put it up there. What happened? Something happened here. Oh, I see. Okay. Okay, here it is. This is the semicircle of mathematics, again, today. And again, you can see the only thing that's missing are the rays. Okay. It says a semicircle is a one-dimensional locus of points that forms half of a circle. And another definition says a semicircle is a two-dimensional geometric shape. No, it ain't. But that forms half of a circle. And then you see what Wolfram has in two of its sites. It says a semicircle is a half circle formed by cutting a whole circle along a diameter line. And another one, a little shorter, concise, half a circle. That's what it is. Okay, what is a circle? Well, it's a bunch of points. What is a point? It's a location. So we're talking about an itinerary, and that's what we have. We have half an itinerary. That was what a semicircle is. Okay, so where does this all lead to? Well, it leads to this. What is Euclid's sphere? Okay, we're talking about Euclid's sphere here, okay? Well, this is it, okay? Actually, no, that's not Euclid's sphere. Let's put Euclid's sphere here. That's not the one I want to show. Let me show this one, okay? Remove this one out of there. Give me a second here. Okay, so this is Euclid's sphere, okay? He's going to take a semicircle and he's going to spin it around, okay? He says this, and he says that that's what a sphere is. He's talking about a solid here, okay? And it turns out it's like a wheel that you turn, half a wheel that you turn around. He says that's a sphere, okay? And the spokes, moving around. It says, when a semicircle with fixed diameters carried around and restored again to the same position from which it began to be moved, the figure so comprehended is a sphere. Okay? What is a sphere according to mathematical physics? Well, you can guess almost. They're going to take that same semicircle and do something with it, okay? And here it is. Okay. Let me put it over here so that you can compare them side by side. Sphere, a solid generated when a semicircle is being rotated about its diameter in three-dimensional space. This is also known as a perfect round geometrical object. No, it's not an object and it's not a figure. A sphere created by rotating a semicircle with radius a around the y-axis. Does your answer agree with the what? Volume of a sphere. Yeah, they're talking about a volume. They're talking about something else. They're not talking about what a sphere is. They're talking about the volume occupied by a sphere. Okay? They're talking about how much water the rubber ducky displaces. That's what it's all about. And then it said the region bounded by x equals 0, blah, 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 will be a semicircle which by rotating about the x-axis generates a semi-sphere whose volume is blah, 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 blah. And then we have the stack exchange again, all these PhDs, and they say, what is a sphere? Rotated half a circle in 3D. Some 3D shapes, like the sphere, are constructed by rotating a planar shape around an axis. No, that's called a volume. That's not called a sphere. Okay? A sphere is a ball. That's what a sphere is. Okay? And so, yeah, all these people... they're building all these things with itineraries. But listen what happens here. Look at this. Let me show this again. Okay? See, that semicircle is first built with it as an itinerary. Okay? Those are locations. So we're talking about a bunch of locations. Okay? We build the first half circle. And then that is an itinerary. But then they're going to move the itinerary around to build a sphere. So we have the motion or the orbit or the trip of an itinerary, of a trajectory, of an orbit, because you have half an orbit and then that orbit orbits. That's what they have. And this takes us to one of the funny things that they have out there, and you'll see why that's related all to geometry in the end, what geometry is really about. And some of you have heard of the tesseract, which is regarded to be a four-dimensional object. And here it is. Here's the analysis for that. And again, you're talking about the motion of motion. That's what a tesseract is. You also have the hypersphere as well, but let's do the hyper cube instead. You have a cube. Listen carefully here. You have a cube, and the cube expands over time. Think of it as a cubic balloon, and you inflate it. So the cube grows over time, becomes bigger and bigger and bigger. Okay, so with that you build that photo of a tesseract, which is what you see on the upper right hand corner there. So you have the beginning cube and the ending cube, and then the growth is shown with these lines that connect the corners. Okay, you understand that? We have the small cube, we have the ending cube, okay, the beginning and the ending cube, and their corners are, their vertices are connected by these lines which represent the motion of expansion. Okay, and there you see the tesseract. So when you look at a tesseract, that's what you're staring at. You're not staring at a cube, three-dimensional or four-dimensional cube. What you're staring at is the growth of a cube, the film of a growth of a cube growing through time, and you're seeing that film in one photograph. Okay, they condensed it, and the lines are just there to represent that motion, that growth motion. Those lines that connect the corners. Okay, that's the first part. Now we take that, remember this is in motion, okay? It's growing, okay? Keep that in mind. We're having a box that's becoming bigger, right? Now they're going to turn that box, but not as it's growing, okay? What they really do is they wait for the box to grow, and then they turn it, give it a different location, a different axis, a different tilt. And then they do it again, and then they do it again, and then they do it again. So we have this box growing. You take a snapshot of that. Now you rotate it a little bit. Now you start again. You have this box growing. You take a snapshot of it and you move it a little bit, and so on down the line. So you have the growth of a cube over time. That film turns into a photograph. Now you're going to take that last photograph and you're going to make a movie of those using those pictures, those frames. Okay, and so we have the motion of motion. That's what a tesseract is. So let's look at this thing in motion so that you can see what you're staring at whenever you're looking at a tesseract, which is the same thing that they're doing with the semicircle, rotating it around and saying that's a sphere. Well, this is the same thing they're doing with the tesseract. And here it is, okay? You've seen the tesseract here. So what you're staring at there is the growth of the in the box on the inside, okay? And this is ridiculous because that's not what it is. What you see is the box is really growing, and the lines that unite the corners represent that growth, and then they move the whole thing around. So we have the motion of motion. We have a movie within a movie, within the frame of a movie. That's what you're staring at. And then you're looking at the movie of each one of these frames. So yeah, the motion within one frame is very scary stuff. And that's what they do exactly with the hemisphere, with the semicircle. They first build this itinerary, which is a curve, and then they move the curve, that itinerary around. They say that's a sphere. We're not even talking about a figure. Okay? But that's geometry for you in a nutshell. Okay, so here are my conclusions. Okay, so that you can take this to the bank. Okay, so let's summarize here. Point is equal to a location. That's what point is in both Euclid and today, mathematical physics. What is a line? Motion. It's an itinerary. Okay, it's a bunch of locations. What is a circle? It's the orbit of a location. It's an orbit. That's what it is. It's not a figure. It's an orbit. It's something moving. What is it that's moving? A location. The location is orbiting. What's in that location? A location. No specified object. What is a semicircle? Well, that's half a circle. So it's half an orbit. And the orbit itself is just stopped. It has a starting point and an ending point, but it doesn't go all around. It just stops halfway. Okay, so that's what a semicircle is. What is a sphere? Well, they take that orbit and they orbit it around. They twirl it around. They say we're twirling the orbit, half an orbit. Okay, they could have twirled the whole circle around, but they said no. We're going to twirl half a circle. We're going to twirl the semicircle around, which is what a semi-itinerary. That's what it is. And then what's the tesseract? Well, the same thing, but in cubic mode. They say, look, the tesseract is just the expansion of a box, okay? And they're going to freeze the beginning and ending frame, connect them with lines which represent the time, the distance traveled, okay, by the expanding cube. And then they're going to take that, make a single frame of the film with that, and then we're going to make a movie with that and twirl that around as well. Same thing for the sphere as for the tesseract. That's geometry condensed in a nutshell for you.